Thor the guinea pig has a beautiful white, tan, and brown fur coat. The reason he has this is because of transcription. Transcription is the process of making an RNA copy from a DNA template. The first step of transcription is initiation. That's where it all starts. The promoters are signals on the DNA that show the RNA polymerase exactly where to begin making RNA. Step 2 of transcription is elongation. Elongation is when the RNA polymerase makes a complementary strand of the RNA from the DNA template. 3 bases of the new strand in a row make up a codon. 1 codon codes for 1 amino acid. Finally, termination occurs. A terminator on the DNA strand stops the RNA polymerase, transcription has ended, and mRNA is made. The mRNA that was made during transcription must get processed before it can leave the nucleus. The mRNA contains sequences known as introns and exons. Introns don't code for anything, while exons code for proteins. The introns are kicked out and the exons are put together. Finally, a cap and poly A tail sequence are added to the mRNA and it is ready to leave the nucleus. The process in which a ribosome reads the mRNA and makes a protein is called translation. Translation has the same 3 steps as transcription: initiation, elongation, and termination. Translation begins with initiation. A ribosome attaches to an mRNA strand and translation occurs at AUG, the start codon. The first tRNA has an anticodon complementary to the mRNA start codon, and it goes to the P site of the ribosome to bind with its complementary codon, and translation begins. The next step is elongation. Amino acids are brought by the tRNA to the mRNA, and they are added one by one to create a polypeptide chain. The final step is termination. The end of translation occurs when the ribosome reaches a stop codon. The 3 stop codons are UAA, UAG, and UGA. The polypeptide chain is released from the ribosome and now a protein is made. This protein that was made gives Thor his luscious hair. A deletion mutation, a type of point mutation, occurs within this important protein of Thor's. A base of a codon disappears and all of the following codons change into a different code for a different amino acid, making Thor bald.